Hi there, we're going to be looking at area of 2D shapes, rectangles, triangles, parallelograms and trapeziums. If we start with a rectangle, it's best to think of it initially as split into centimetre squares. So if we have a look at this one here and split it into centimetre squares, you can see that for this particular rectangle it's got a height of 3 centimetres, or width if you prefer, and it's got a length of 6 centimetres. And when we're trying to find the area, we're basically trying to work out how many centimetre squares it fits inside. And as you can see, it's 6 by 3. So the area is the length times the width, which is 6 times 3. So it's 18 square centimetres, or centimetre squared, because there's 18 squares that fit inside that particular shape. Onto the triangle, we can relate it back to rectangles in that the length and the width, you can look at it like a rectangle. So we've got length here. Now you'll normally see this referred to as the base, and this as the height. Now if I were to do base times height, excuse me one moment, so if you do the base times height, then what you'd actually get is the area of the rectangle. Now that triangle is half of that rectangle, so if we get rid of the rectangle there, what we need to do to find half of it is divide it all by 2. So the area of a triangle is base times height, and then halve it. It's very important that the height is vertically up, like you're measuring the height of a mountain, rather than measuring the slope. Moving on to the parallelogram, again we can just relate this back to think of it like a rectangle. So at the moment we've got like a rectangle that's fallen over. If I take this end, pick it up and put it on the other end, you'll see I've just got a rectangle again. And for that reason, once again, I can do the base of our rectangle, which is also the same as the length of one of the pairs of the parallel sides of our parallelogram, and then I can do the height of our parallelogram, and you can find the area of the parallelogram by doing base times height. If I just go and put that back, so we've got our original parallelogram, and I take this and put it at the top here, you'll see that you can use the length of one of the parallel sides times the height, and that will give you the area of the parallelogram. The trapezium takes a bit more work, so if you were to take a trapezium and make an exact copy, flip it around and stick it on the end, it looks like that. So what we actually get is, if you've got your two parallel sides of your trapezium, I'm going to call that one A, I'm going to call that one B. So if you imagine I've taken that trapezium, turned it upside down, that will be B, and that will be A. And it's just like our parallelogram now. So actually what I'll need to do is do the base, which is A and B added together. So the area is the base of that times the distance between them. So height, just like in the parallelogram. But remember, I've created 2 of these, and I only want to find the area of 1. So to do that, I'm going to need to divide by 2. And if I just highlight, we've got our formulae now for the area of a rectangle, for the area of a triangle, the area of a parallelogram and the area of a trapezium. And those are the formulae you'll need to remember and apply in a moment. You may want to pause the video, look away, try and write down those formulae, see if you can remember them, and then sort of check back and see if you've got them committed to memory. We're going to move on now to try and apply those formulae to some problems. So we've got a rectangle, a triangle, a parallelogram and a trapezium, and we're going to work out the areas of those. So for this one, the area of a rectangle is length times width. The length of our rectangle is 7 centimeters, the width is 2 centimeters, which gives us an area of 14 centimeters squared. For the area of our triangle, pause it now if you can and see if you can remember the area of a triangle formulae. So hopefully you remembered it was base times height and then halved. So this one will be 5, and you'll see this number here. Now if that was referring to the length of that side, then that's irrelevant to me, but if it's the vertical height, then it is useful. So we've got 5 times 6 and then divide that by 2, which is 30 divided by 2, so that'll be 15 centimeters squared. Centimeters squared because it's how many squares fit inside these shapes. For the area of a parallelogram, we've got base times height. So once again, it's important that that 7 centimeters refers to the vertical height and not any slanted one. So this one here will be the base is 4, the height is 7, so that's 28 centimeters squared. And then finally we've got our trapezium. Once again we've got this 4 centimeters. Let's make sure that refers to the vertical height. So our area is the 2 parallel sides, which remember that was A and B, so we add those two together, times them by the height, and then divide by 2. So we've got 1.5 plus 4.5 times by 4, and then we divide that by 2. 1.5 plus 4.5 is 6. 6 times 4 is 24. Divide that by 2 gives us 12 centimeters squared. And you may be hear in the background that my son is stirring, so that's probably a good time to finish. Hope it was useful. Best of luck with the questions.